Alright, our second process is hot forging. What is hot forging? Hot forging is another hot working process, a process of shaping the heated metal into products by means of dies and tools using impact blows and pressure. So under the category of forging, we have 4 different types of forging. Yeah, we have the hammer or smith forging, we have the drop forging, we have the upset forging, and the hot press forging. So the first two that we're going to look at, hammer and drop forging, uses the technique of impact blow and pressure, whereas the remaining two, upset forging and hot press forging, uses the technique of squeezing. So let's look at the first one, hammer or smith forging. So for hammer or smith forging, the parts are formed by shaping the heated metal in flat open dies by means of impact blow, meaning that you're actually, rule number 1, what are you going to do? You're going to heat up the metal above recrystallization temperature. When the material is in semi-solid state, you're going to use some kind of shaping technique. And what is that some kind? You're going to actually use a hammer and physically shape that object into its final product. So if you look at it over here, the first diagram, okay, that is hammer forging. Okay, this top one, yeah, this is hammer forging. So hammer forging, you're going to use a flat die. Okay, this is a flat die, and you're going to put in your object, whichever that you want to shape, and you are going to apply, you're going to heat it up above recrystallization temperature. Once it's heated up above recrystallization temperature, you're going to put it under the flat die, and you're going to have an impact blow, okay, by the hammer. This is your head hammer. I know you're imagining a real life hammer, but in manufacturing, this is how your head hammer or your hammer is going to look like. So you're going to use the hammer, and the material is in semi-solid state, so it's very easily shaped. You are going to hit on it randomly and shape it. So hammer forging, because it uses an open flat die, you find that the process is less accurate compared to drop forging. So let's look at it. Hammer forging, disadvantage, low quality and accuracy of the product, because you're using a flat die and you are doing it manually. That means one is by trial and error, and one is by professionalism, because if you're a professional, you'll be able to shape it using your intuition, meaning that you can estimate the final product, and you're going to manually use the hammer and shape it at a temperature above recrystallization temperature. Therefore, there's a chances of obtaining a low quality and accuracy of the product. And obviously, as I told you, because you're using your intuition, not any person can conduct hammer forging. It has to require high skill operators, and it's a very dangerous process because you may get hurt during the process. Yeah, you have high impact blows, and you may get hurt during the process. So that is hammer or smith forging. The same exact process is drop forging. Drop forging resembles hammer forging, but in the case of drop forging, it uses closed impression dies instead of flat open dies. So the forging is still accomplished using impact blows and pressure. So in this case of drop forging, you're going to use a steam hammer or an automated hammer. So unlike a hammer forging where you're going to use a manual hammer, in drop forging, you're going to use a steam hammer. So how does it look like? Let's look at it first. How does it look like? You have your hot forging or your hammer forging on the top, and the bottom one is your drop forging. Your drop forging is not flat. Now you see this is a flat. So your surface is going to be, for your hammer forging, your surface is limited. You're going to only get a flat surface. Whereas in drop forging, it can even your die can be of any shape as long as it's symmetrical, and your object is going to follow the shape of your die. So drop forging has an upper and a lower mold, and you get a more defined shape and a more accurate shape as compared to hammer forging. So in drop forging, if you look at it, same exact concept. You're going to heat up the a material to above recrystallization temperature, and when it's in a semi-solid state, you're going to put it under the hammer. Now we're going to use an automated hammer in order to shape the object. Again, please do not picture the exact hammer that we use in our daily life. This is a manufacturing hammer, so it functions the same way though. So you're going to have high impact blow, just like you use a home hammer. Yeah, this hammer also functions the same way, but the difference between hammer forging and drop forging is now drop forging is going to be done automatically. So you're going to have an automated system. Therefore, you get consistent impact blows. So when you get consistent impact blows, your shaping process is going to be much more consistent and much more accurate. So as you use the automated hammer and you hammer it down to a more specific shape. Okay, so you'll have a symmetrical, more specific equilateral shape, and your finishing is going to be more accurate as compared to hammer forging. Okay, let's look at the advantages and disadvantages of drop forging. First of all, the advantages: you get a fine grain structure that is standard. Yeah, if you remember hot working, what happens to your grains? Your grain structure from coarse grains, you're going to heat up the material to above recrystallization temperature. Your grains collide with each other, break up into smaller particles. Subparticles will rearrange itself in a more orderly manner. Therefore, you end up getting a fine grain structure with no voids. Okay, so you get an excellent grain structure. An excellent grain structure meaning excellent mechanical properties of your final product. Number 2, less porosity and voids. What do I mean by less porosity and voids? As your grain structure rearranges itself in a more orderly manner, you're eliminating all the voids. What is voids? In Malay, ruang kosong. Yeah? You're eliminating the voids. You do not want to have voids in your product. Why? Because voids are considered weak spots in your product. If you have voids in your product, meaning that if there's an impact, you suddenly drop the product, a crack forms, the crack will propagate through these voids. So as much as possible, you want to eliminate voids from your material. Okay, number 3, eliminate of some mechanical operations. So you can eliminate some mechanical operations. Number 4, improve physical properties. Your density increases, your physical properties increase. You have much better utilization of material because now you have your mold, a predefined mold, and your object at a temperature above recrystallization temperature is being shaped to the shape of that mold. Okay, so you have better utilization of material compared to hammer forging, because now in drop forging you're applying closed dies. However, just like any manufacturing processes, just as you have advantages, it also comes with disadvantages. So what is the disadvantages of drop forging? Number 1, crack can occur. So even though you're using an automatic hammer, as you keep increasing the pressure of your impact blow, there are times when your material can crack. It can no longer take the impact, meaning that the material has probably undergone or exceeded the ultimate strength. The impact blow has exceeded the ultimate strength of the material. Remember the stress strain curve, there's 4 stages: elastic limit, yield point, ultimate strength, and fracture. So now in this case, when your material cracks, the material has undergone ultimate strength, meaning that the impact blow force has exceeded the ultimate strength of the material, therefore leading to the crack of the material and finally the complete fracture of the material. Okay, number 2, high cost of dies. What is a die? Your mold, acuan, yeah, your mold is called a die. So for you, as I mentioned to you previously, yeah, your material is shaped at a temperature above recrystallization temperature. So your mold has to be heat resistant, number 1. And number 2, because you're using impact blows and you're impact blowing on the mold, your mold has to be strength resistant. It has to be very, very strong and does not break at every impact blow that it receives, right? So for that to happen, your dies are going to be a very, very costly affair. It's going to be very expensive to manufacture high grade of dies in that case, yeah. You may have difficult die alignment. Okay, sometimes you may have difficult die alignment because your dies are not going to be static. It's going to be subjected to continuous impact blow, and sometimes during that automated impact blow, your dies may vibrate, may move. Okay, so you may have some misalignment. So all this can occur in drop forging, but generally drop forging is much better in terms of material utilization and a final dimension of the product. Okay, so again, a quick comparison between hammer and drop forging. Drop forging uses close impression dies, okay, meaning that you have the upper half and the lower half of the mold to shape it perfectly to the shape, whereas in hammer forging you have a flat die. So you have the upper and lower portion, you have a flat die, and the material needs to be further shaped after that. In drop forging, materials are better utilized, so better material utilization in drop forging as compared to hammer forging. Drop forging, obviously, okay, because of its close impression dies will produce more accurate parts. Okay, so that is impact blow, yeah, hammer forging and drop forging. I did mention to you previously that there is two categories of forging. Hammer and drop is using impact blow. Upset and hot press forging is using squeezing or pressure, yeah. So let's look at the third one, hot press forging. What is hot press forging? Hot press forging differs in operation, meaning that now instead of using a hammer, you're going to use pressure. You're going to use slow squeezing action to shape the product. So normally you're going to use a hydraulic or a mechanical press in this case, yeah. So please do not worry. If you look at the formula, it's a very basic formula. Pressure equals to force over area, where pressure is in pascals, force is in newtons, area meter squared. Okay, so it's a very basic calculation, yeah. So if you need to know how much of pressure to apply during your hot press forging, you must first of all determine the amount of force and the area of your product. Okay, so that's when you can calculate amount of or the correct amount of pressure that you have to apply during your shaping process. Okay, so if you look at upset forging and hot press forging, yeah. So upset forging, is you're going to create an upsetting operation, yeah. So it's normally used in making of nails, screws, yeah. So what happens is you have your metal piece, you're going to clamp or you're going to grip it with a die, with a acuan, you're going to grip it. What you're going to do is you're going to shape the front part. Okay, you want to transform it into a screw head or a nail head. So what are you going to do? Step number one in any hot working process. Step number one, heat it up above recrystallization temperature. So once you heat it up above recrystallization temperature, the material becomes semi-solid and you are going to apply your die. When you apply the die, what's going to happen? It's going to follow the shape of your die. So if it's a screw head shape, you end up getting a screw head shape. Then you allow it to cool back to room temperature. As I told you, shaping is much easier because you're shaping at a temperature above recrystallization temperature. The material is in semi-solid state. So it's semi-solid, it's very soft. Once you apply the screw head, the soft edge will transform into a screw head. Allow it to cool back to room temperature, and then you can create your threads and complete the nail making process. Okay, that is upset forging. You create a sudden upsetting action at the beginning or the front portion of the nail to create the nail head or the screw head. What is hot press forging? Hot press forging is like plasticine, yeah. How does plasticine work? Yeah, if you have a particular shape, you take a plasticine, you stuff it into it, and you level it up, and then you remove. When you remove the plasticine has followed the shape of your mold. Similarly, jelly. If you pour in liquid jelly into your mold, you let it solidify, and you eject the jelly. It has followed the shape of the mold. Same concept. You already have your mold. You're going to heat up your material to above recrystallization temperature. You are going to put it into your mold, your arch one, and you apply. You're going to compact it, or you close up the mold. The semi-solid object will spread up and it will fill up your mold. Okay. Once it fills up the mold, you allow it to cool back to room temperature. Open up your mold, and you have your finished part. So these are the 4 processes under hot working, hammer and drop forging, which uses impact blow as a method of operation, upset forging, and hot press forging, which uses pressure as a method of operation. So that is our hot working process. Besides that, you have a roll forging, you have hot extrusion. Hot extrusion is when you heat up the object and then you use a press machine and you extrude, or you're going to pull the edges, and the material will stretch. There'll be an increase in the length of the material and a decrease in the dimension or the diameter of the material, and then you allow it to cool back to the room temperature. Always, yeah, hot working, the keyword is heat it up above recrystallization temperature before you shape it. Okay, so that is hot extrusion. Okay, and see, so this is an example of hot extrusion. So you have your material, you put it up, you heat it up above recrystallization temperature, you apply force to it, and this is going to be your final work, or this is going to be your diameter at which you're going to extrude it. You're going to stretch it to a much narrower diameter, so there'll be a reduction in the diameter. This is your original diameter, yeah, original diameter, and this is your final diameter. You're going to extrude it through your final diameter, but it's going to be very easy because the material is in a semi-solid state. You stretch it out, and there'll be a reduction in diameter, increase in the length of the final product. Okay, so what are the advantages of extrusion? Any shape of cross sections can be produced. Any shape, yeah, you can do it to a rod, you can do it to a bar. High accuracy of product. You apply, or you end up getting a good surface finish. High production rate. Unlimited length can be produced. Okay, you can extrude to any unlimited length. You have 2 methods of extrusion: direct extrusion and indirect extrusion. Others, impact extrusion. Okay, we have drawing, and that's it. Okay, so this ends our chapter. Okay, so please go revise back, look at the previous video on hot working, and try to comprehend what I've said. Okay, so remember, keyword for hot working is heating up above recrystallization temperature, and then shape it, because once the material has gained energy, the grains will vibrate, collide with each other, break down, rearrange in a more orderly manner, and you'll have much better mechanical properties of the material. Okay, so that ends this hot working chapter. That's all for today. Thank you very much. Until I see you in the next lecture, please go through all your materials and comprehend what I've said up till this point in time. I'll meet you again in the next video on cold working. Thank you. See you later.